welcome to the Qapla' drill, Q, in our alphabetical order. And this is the Promethei section. So this section is dedicated to scouts and explorers. And scouts, by my definition, are people who do life-supporting information gathering and problem solving. And explorers are like discoverers, where they dare to go, bravely into the unknown in order to help, better humanity, to increase knowledge. So, and both of them risk a lot. A lot of times, them putting their lives on the line just to increase that knowledge and skill base, for the betterment of humanity and life on Earth. And they usually deal with two kinds of threats, life threats. One is from nature, which I would call imbalances. So imbalances are threats to life. And then there's threats of life-destructive threats that are from other humans. And we call those violations of the life value. So either way, discoverers and explorers have to, bust through these obstacles. And when we start going through the 22 variables, you notice like the first 4 of the variables are a little odd. And again, they are Humphrey's conditions. Actually, the first 3 are Humphrey's conditions. The 4th one is mine. The 3 conditions where someone will put their life on the line or risk their life in order to help others. Okay? So you have the obvious need. Okay, there has to be a life threat, and it has to be obvious. The second one is a skill base, where someone has actually it's reason, where someone is not panicking. They're able to control their emotions or their passion, and able to clearly think through for problem solving. And they come to realize that the third thing, which is they have the skills, they have the confidence to be able to pull something off. Okay, can I do this? Can I help everybody if I do this? But the 4th thing, which is my own addition to Humphrey's 3 conditions, is means and resources. Because a lot of times it's not just skill alone. If you are without the instruments you need to be able to perform that duty, it's not going to get done. A famous story is Humphrey's bazooka story. When they were on Iwo Jima, and that could not have happened if they did not have a bazooka, let alone skillfully use it. So the same thing could be said for a surgeon, where he can't operate without a scalpel, or people can't practice healthcare without gloves for protection. So things of that nature. But when you look at those 4 conditions, I call them, you still are going through the PADPI process, because the first thing is need. There's obviously a life threat or some kind of threat. Something that is potentially life-destructive, an obvious imbalance or violation that needs to be remedied. And then you have assess, diagnose, and plan. And that's with reason. You do that with reasoning abilities. And then you have the implementation process, and you have skills and the means or the resources to be able to pull that off. And so it's kind of another way of saying that, how all of that kind of just comes together. So now, to kind of go off on a bit of a tangent of where we're going with the Kapladro, or at least back on track, I should say. If you take these vocations, these roles, scouting, exploring, discovering, and we add a lot of technology to it. You know, one of the famous cultures that's come up with putting that together is the Star Trek culture. And I'm not going to say I'm a huge fan, but you know, I've followed because I am completely fascinated as to how humanity will be dealing with problems in the future, especially involving advanced technology, and how we have relations with different people. At least in the show, it's different species. So, but it's a very intellectual show, and it really does go where no one has gone before, kind of thing. So that's really the theme of this one, and so I like it because I learn a lot on the show, because it pushes your problem solving awarenesses like that. So, all right. So let's take, for example, what we do here in the Fire Dojo, which is structure, variables, function, or you could do the reverse, right? Function, variables, structure. So the saying in Star Trek is basically IDIC, which is infinite diversity, infinite combinations. And if you watch Star Trek, you've probably heard that saying before, but it's a very important one, because no two snowflakes are ever alike, right? Nothing in the universe, no atoms are ever in the same arrangement, ever. No matter how close they look, nothing in the universe is exactly the same. So everything is an infinite variation, which is what we push here at the dojo, that there's nothing ever the same. No matter how many structures you see, no matter how many structures you create, they're all going to be different on some level, no matter how close they are. So, there's something that I don't like about the show, and that's always a pet peeve, and it's something that they can never seem to get right. They haven't fixed yet, and that's the Prime Directive. I can't see humanity going as such an advanced society without realizing that the life value is probably, in theory, the standard by which all things should be measured. So I can't imagine being an explorer, going out into space and going, well, our main value, our top value is non-interference. Well, then you've pretty much canceled out your ability to perform duties to help others. So that doesn't seem to make sense at all. So I hope they fix that someday. Because non-interference, as they've shown on the show sometimes, that it's not always a moral value, right? There's relative values, then there's moral values, which are life-supporting, which is what makes them moral, and then there's ethics, which are moral values in action. And so there are times when the Prime Directive is life-destructive. So that doesn't make it a moral value. And then, therefore, there are no ethics, because you're not doing the right thing. It's a shame, though, because I think it would really improve the show, the culture, the Star Trek culture. Anyway, I've created a backstory here, and if you're not familiar with Star Trek, the backstory may be a little hard to follow. Sorry about that. However, the method that is outlined in the story is real, because you are about to see something performed that's never been done before. So here's my disclaimer. I obviously don't have or own the rights to Star Trek. I have nothing to do with Star Trek, or the Star Trek universe, or anything like that. So that's my disclaimer. So my backstory is merely a fan fiction whose function is to express the dedication to scouts and explorers, to scouting and exploring the unknown for the betterment of humanity. Okay? Or better known as to go where no one has gone before, but for the betterment of all. All right. So here's the Qapla' drill. Hope you like it. I had fun doing it. Okay, so here is the Qapla' drill. As you can see, it's held in place with hose clamps so that it doesn't split as I use it to turn it for torque. Okay. I didn't want to screw it in because if ever I have to replace the spindle on it, I don't want to have to find those same exact holes that go through the bat lathe, and I don't want to mess it up with that. The plug is in. I took out a little bit of the dead space center, not a lot, maybe about 3/4 of an inch. And I have down here as the base, since it's rattan, it's the same base I used for the rattan toggle drill, the giant rattan toggle drill that I had thrown together. So I'm reusing that. Oops, wrong way. So the top is pointed, but it's not mated. But I'm greasing it up anyway. And hopefully that'll work. Well, I expected it might burn anyway, but we'll see. So we lift up our lever, that's going to be filled with weights, and the top goes in first, and then the bottom slides in right to the base. Okay. It's going to have a lot of torque turning through. Now we need to apply the weights. So what I'm going to do is go get my weights and fill this up and be right back. Okay, so I put the weight up top, and there's a lot of weight up there. The total comes to 53.5 kilos, or 117.7 pounds by my total. All right, oops. So I'm going to stand behind it, and I'm going to start moving this thing back and forth and see how it goes. Okay. Now I only have a little bit of coal dust stuffing in there, just to kind of fill the notch up a little bit. You know what? I'm going to put a little bit more, actually. Just some sawdust that's on the floor. I have a feeling this is going to take a while, but I need to definitely save on energy and work. Excuse me. Oh. Alright. So the goal of this is to do half rotations, right? Because with the that little mechanical device that I did as a side note for the bow drill, you know, back in the day, that was one full rotation. So if I pull the lever down or up, that would be one rotation around. And we know that we can get a coal from just doing one rotation back and forth. So can we get a coal doing half rotations back and forth, and something of this size as well? Alright, so let's see if we can't recreate what happened. Alright, let me get this one position here. I just have to be careful this thing doesn't fall on my head. It's smoking. It's starting to drift. It's starting to drift out. So what I'm going to do is, that means I got to take all the weights out. is I'm going to move the base over so that it's centered better. Alright, so let me go do that. I probably never mentioned how much fun it is to take weights up and down off this thing. So I moved the base back so that's angled backward. Okay. I replaced the bases, by the way, are Douglas fir. I switched these two around, is what I did. So it's angling backward instead of forward, and drifting forward, because what it's doing is it's absolutely drifting into the notch. It's even started, I could see that the circle has gotten bigger already. So it's what I mean is it's like oval. Alright, here we go. I'm just going to take it nice and easy and warm it up. So we're doing half turns back and forth. And it's smoking already. And oh, by the way, before, there was a good pile of coal dust already started in there that I created. It was a shame to have to let it get cold and stop, but I had to fix that complication before it really became a problem. Let's keep going, keep going. Half turns. Keep going, keep going. Let's have a look. And we have a coal, ladies and gentlemen. So, let me close up in on that. Now the problem is, to take this apart, I have to take all those weights off. You know what? I'm going to remove the front base. And there we go. You see that? Half turns. Only half turns can be done on the Qapla' drill. Rattan on Douglas fir. Now we know that rattan on Douglas fir does work because we did the giant toggle drill with that, but here we only did half turns, back and forth. Alright, it can be done. Alright, let's keep going. Okay, so here we're ready to begin our scientific method experiment of the Datang knife. Okay, so the story goes is that the knife inserted into the spindle is replacing the batleth. Okay. And just so you know, up here, inside our experimental toggle box is the same amount of weight as we did with the batleth, which is, I believe, 117, a little over 117 pounds. So, or I think it was 53.5, something like that, kilos. Whatever the last weight was. And so here, the other thing too is we're going to push the limits more, according to the story. We're not going to do 180s. We're not going to do half turns. We're actually going to do quarter turns. So I've outlined here a 90-degree angle, and I've placed 1-foot nails inside to mark that 90-degree or 1/4 turn space. So our reloading spindle is ash with an ash spindle reload on an ash base. So the core 2 is ash. Now we're just going to be mating these together for now. There's no notch in there. So we're going to get this warmed up and mated, and then we're going to take it out and do the notch. Okay. And you can see it's smoking pretty good. Okay, we're going to call that mated. And so I'm going to take all these weights down, my favorite thing to do, and put a notch in there. I'm going to fill the notch with dust, pre-fill it to save on energy and work, and see how it goes. The dust is a little light brown right now, but if we keep going, it'll probably darken up. All right, let's keep going. So I've taken all the weights down, as you can see. I put a notch inside my ash reloading base. It's held in place with nails, which I'll show you. Let me take this down. Sorry about the lighting. It's getting dusk. The sun is setting, and I have these other lamps on, but it's not really doing the job that I want. So I'm gonna put the weights back in. I'm gonna set the camera up so you can see the notch better, and we're gonna fill the notch with some dust, and let's see what happens. Okay, so we're ready to start our test. I filled the notch with some sawdust, okay, and put all the weights back on top. Now, if you don't know this knife, culturally, there's spikes on the end. I mean, it's dulled down here in our replica, but you can't put your hand over here because there's these spikes that stick out. And obviously you would stay away from the blades. So this knife is basically held this way so that it's pulled and pushed in this manner. Okay, so let's go. Here we go. Just gonna take it nice and easy. Now, obviously, if you don't hear the clicking, I haven't even gone a whole 90 degrees. starting to fill with dust. We're getting some smoke. It's starting to darken. I'm gonna go faster. Let's see what we have. Nope, not quite just yet. But I'll tell you what I'm gonna do. I'm gonna take a quick rest and leave everything the way it is and come back. Okay. Okay, so we're ready to try this again. And what I'm going to do this time is actually start with my left. Start with my left and get it really warmed up. And then I think to try to get it ignited, I'm going to use my right. I'm going to switch. I might have to switch again. Oh, you're not going to believe this. Well, I did cut the base at a funky angle, so it started to drift out. Let's take this nail out. Can you see? It's drifted out off the base. I got a good pile of dust backwards. Alright, so I did make another hole on the side. So I'm going to reset this up. And you know what I'm going to do? I'm not even going to mate it. I'm just going to cut the notch and go for it. Alright, let's try again. Okay, so here's the base. You can see it drifted over toward the notch, but if you look at the base this way, you can see it slopes down. And that's the one I used first. I should have probably picked this one first. But then we did learn. I mean, all that massive weight, it's probably no surprise. See, it even started busting out. You can see here. Out of there. Look at all that dust. Good color too. You could see where the dust here was in the notch area on top of the sawdust I had in there. But look at this dust in the back. How all that came over back the other side. So I have a couple of complications I need to fix before we begin again. I had to cut flush the bottom of the ash spindle reload because it was messed up from the drifting. So I flattened it. But what it's also done is it's burned down, and since I cut some off, that has pretty much shortened the length of the spindle, and I'm afraid that the top lever here is actually going to hit the safety, and then I'm not going to have any pressure at all. So in order to fix that problem, or at least balance it out, I've taken a piece of pine, and that's going to fit in there first, and that's going to raise up the base to make this spindle just long enough. Alright, so I'm going to nail that in to secure it, and I'm going to get all this set up again and try it again and put the dust back in the notch. Alright, be right back. So it's the next day, and I think I've tried to balance all the complications as best I can, and we got a lot of light this time, especially since the sun is out a little bit. And I'm going to do what I did again. I'm going to start with my left to get it warmed up, and then work with the right to try to ignite it. I got the nails in to maintain that 90-degree angle, and let's get started. Trying to use more of my legs to move my body back and forth instead of using my arm muscles. And there's smoke in the notch, and it's hard to see. I'm going to switch arms. Again, the dust is coming off the back end, as well as in the notch. It's really pouring out. That's a lot of pressure. Doesn't seem to be drifting. There's a lot of dust. Okay, I'm going to stop. And so it's kind of a medium brown. It's obviously not a dark brown that would show ignition. So I might have to use a softer wood. I think that the pressure is not, there's enough pressure, but the friction is too much abrasion friction and not enough temperature friction. Or maybe if I take the nails out and we do 1/2, maybe that would raise the temperature up. So let's try that before I go to a less dense wood. Alright? Okay, so we're going to try the 180s, the half turns. And I think that's what's going to compensate for the high density of the ash. When we did the batleth, we did rattan on the Douglas fir. So we're going to try half turns here. Then we're going to switch to a lower density wood and try the quarter turns then. Okay? Here we go. It's warmed up. A lot of dust pouring out. Let's see. You know, I think we were close. I'm gonna try and keep going. I'm gonna switch halves this side. Switch again. Switch again. And we got it this time. All right. So here's what we know. Ash is possible as a hardness, as a density. But with a longer duration and half turns. Oh. That was unexpected. The pieces of the coal are so big that it acted as tinder and ignited its flame. And I have to say, I've only ever seen that happen one other time. And I'm glad to have caught it on video. All right. We're going to do a softer wood. I think we're going to go back to the rattan and Douglas fir and do quarter turns. Okay? Come back. All right, so we're ready to start again on the Qapla' drill. It's still the knife variation, and we've replaced the spindle reload with rattan, and the base is Douglas fir again, like with the Batleth version. And so now we're going to try same weights, the same amount of weight, but this time quarter turns instead of half turns. Okay. So it's mated enough. I mean, I haven't mated it, but the spindle fits into the base very well. So we're just gonna kind of mate it, warm it up, go for it kind of thing. So here we go. Starting to smoke already. And you can hear the sound change. Now I have some dust in there because it's a very, very high notch. So this is going to take a while. And I'm just going to keep switching back and forth. I might even have to make a coal dust pile and then rest and then come back again. You might have to do that. By the way, the spindle reload on the Ash, that was 1 1/8" in diameter. This one, the diameter on this, the surface area, is 1 3/4". It's almost 2 inches in diameter. And our dust is just the right color. Let's keep going. And I think we have a coal. And we do. And that's why this is called the Qapla' drill. Success. We have success. So it can be done quarter turns to do a drill axis method if you have enough pressure, or the balanced amount of pressure. So here I'm going to follow up with epimethei and the finishing story. And but from here, this is Qapla' drill Q. So now we're moving on to R, the rig drill. All right, I think you're gonna like that one too. All right, let's keep going.